Alright, here we are, page 2 now. The rest, this page is going to go pretty quickly because I'm not going to walk through these examples like I did the first two. I'm going to ask you to pause the video and work out these two examples on your own. Okay. One thing I want to reiterate here, well, before I do that, example 1 and example 2 are exactly the same kinds of problems that we just did on the first page. Okay, the one thing that I keep referring to, the Taylor series that I keep referring to, is right here. So you have a nice clear example, nice printed out here example of what f of x and how f of x is represented as an infinite series. Okay, now a couple things I want to point out. Number one, we call these Taylor series. Brooke Taylor is the mathematician who gets the credit for these, but and that's why we call her Taylor series. But then there's a Maclaurin series if the Taylor series is generated by f at x equals 0. In other words, if the Taylor series is centered at 0, then it's actually a Maclaurin series. So a Maclaurin series is a specific Taylor series. It just so happens that the Maclaurin series is the Taylor series at x equals 0. At any other value for x, we just call it a Taylor series, and we will get to that. Okay, now the second thing I want to point out is we talked about how we have an infinite number of terms, and then all of a sudden we're asking for a Taylor polynomial. Well, a Taylor polynomial of order or degree. So this is order is another word for, let me write it in color, another word for degree. Okay, so let's not let that confuse you. Okay, so if you see the word order, it just means degree, and it just means that that's the highest power that you can have in that polynomial. Okay, it's not the number of terms. I want to reiterate that. So that being said, sometimes we want a polynomial. Well, you're doing the same thing. You just don't have an infinite number of terms when you're dealing with a polynomial. Okay, so those are the things I wanted to point out. And as the weeks progress, the days and weeks progress, hopefully the terminology becomes part of your normal vocabulary when you're discussing these types of problems. It's very important that you understand the vocabulary. If you have to replay the video or whatever, do what you need to do to make sure you can explain these problems, and then you will have very little difficulty doing transitioning between one type of problem and another. So in just a moment, I'm going to replace what you see here with the finished product of example 1 and example 2. So if you don't want to see any more, pause the video. I encourage you to do that, just that, and do examples 1 and 2. So here we go. And here we go for example number 1. I think some of you probably like to see the whole thing at once. Let me do this. So Taylor coefficients, I first found the f of x. So f of x here we were given, found the successive derivatives. We wanted a 4th degree polynomial. Where's my 4th power? Oh, right up there. So the 4th derivative is right up there. And I used the derivatives to find the coefficients. And here you see the finished product right there. So let me make sure you can see that 4th derivative and then the finished product here. I feel like I need to do something here, like highlight it. So there you go. Okay, and I really should have just written this as minus x squared over 2 instead of 2 factorial because I simplified all the other terms. But there you go, and hopefully you got that right. And now example 2, just going to cruise right on down here. And example 2, there we go. A 5th degree Maclaurin series and basically saying the same thing. If you see Maclaurin series, so this is the first time I should say that you have seen the words Maclaurin series when you're being asked to construct a polynomial. Okay, it's the same thing as saying construct a 5th degree polynomial centered at x equals 0. So that's what this means. So you got to know that. Centered at x equals 0. That's what that means. If it says Maclaurin, it means it's centered at x equals 0. If it says create a fifth degree Taylor polynomial, well then they will also give you the information of where you'll center that Taylor polynomial. Okay. So anyway, there you go. I guess I should probably highlight this like I highlighted the other one. The other one was in green, so I better do this in green also. I don't want to throw you guys off. So there's the simplified version of your fifth degree Maclaurin series or Maclaurin polynomial. Okay, so that's 5.5 minutes. We'll get you in the next video.